All right, good morning to everybody. Thank you as always for tuning in. I'm Mike Albertson. I'm the Deputy Director here at the Center for Global Security Research at Lawrence Livermore National Laboratory. Today we're delighted to hear from Dr. Aaron Bateman, who's Assistant Professor of History and International Affairs at George Washington University, for his talk titled Weapons in Space, Technology, Politics, and the Rise and Fall of the Strategic Defense Initiative. His talk is going to be based on his book of the same title, which is coming out from MIT Press this year. And I'm going to put a link here in the chat to his book when I'm not talking, so when he gets done. Topical subject, as always, for this audience. You've got a solar eclipse today, so space is on your mind. Russian space weapons, of course, have been in the news. And for those of you familiar with lab history, Livermore, of course, was quite central to the Strategic Defense Initiative story. So you'll probably hear the lab come up a little bit over the course of Aaron's presentation. He's going to get into this over the course of his talk, but he has gone back. He has looked at some archival documents. He sort of explored how this very interesting period in time, the late 70s, the 1980s, where people were talking about the militarization of space, wall relations between the superpowers, the detente of the early 1970s kind of collapsed into open competition, and sort of how this tension played out, how this story played out. And of course, this is a topic that a lot of our speakers touch on, particularly those who are coming to present books, is this idea of going back and looking at Cold War history. Not necessarily because Cold War history is going to repeat itself or the story is going to be the exact same this time around, but it's always because there's some lessons to be learned from history about great power dynamics, about concepts like stability and instability that get tossed around all the time, about relations the United States has with its allies and with its adversaries, and about interaction between policy leadership and science and technology experts here at the lab. So very fortunate to have Aaron with us. Let me say a little bit more about his background. In addition to his position at George Washington University, he's a member of the Space Policy Institute at the Elliott School of International Affairs at George Washington. His research focuses on the relationship between technology and international security. He's looked a great deal about space policy, but also at nuclear operations, at intelligence. He has a forthcoming his book, but he's written a great deal in other publications like Foreign Affairs, Diplomacy and Statecraft, Intelligence and National Security, the Oxford Handbook on Space Security, Journal of Strategic Studies, Bulletin of Atomic Scientists, War on the Rocks, just a host of other issues. He also has some Russian, which is always useful, which I always enjoy. He got his PhD in history from Johns Hopkins University. So ground rules for those of you new to the CGSR experience. He's going to deliver, he's got some slides. He can deliver his remarks for 30 to 45 minutes, at which point we'll open the floor up for discussion. Feel free to type your questions in the chat. Just make sure I and the other panelists can see them. Please raise your hands electronically at any moment, which will allow me to then, as soon as Aaron gets done, sort of jump in the discussion. So with that, Aaron, over to you, and I'm going to put the link to your chat here in the book for interested people. Thanks very much.
So I'll just to repeat, just want to briefly state why I wrote the book in the first place. So when I was at the Pentagon before I was in academia, I realized that the Strategic Defense Initiative is something that really looms large in conversation about arms control, the nature of the end of the Cold War, but I realized that there hasn't actually been much substantive work done on the nature of the program and how it evolved over time and how it affected U.S. relations, not only with the Soviet Union, but also with the transatlantic allies, because SDI was such a great source of controversy. Before I jump into the book, I just want to spend a few moments busting a couple of SDI myths that I think are pretty common. And this is by no means a comprehensive list. But myth number one is that Ronald Reagan pursued SDI to bankrupt the Soviet Union. And that's just really not the case at all. Ronald Reagan really believed that strategic defense, that being able to come up with a comprehensive defense against Soviet strategic nuclear forces was indeed possible. And that really was the central aim of this effort. Myth number two is that SDI was a space laser program, one of my favorite ones. As you will see in the course of this presentation, lasers, directed energy weapons of all kinds were overwhelmingly a small portion of the program. Myth number 3 is that Soviet officials believed that SDI was a techno bluff, that they didn't actually take it seriously. I went through quite a lot of archival material from the former Soviet Union, and we find that the Soviets were indeed very concerned about SDI and the potential for the United States to actually deploy both land and space-based missile defense capabilities that would undermine a significant portion of Soviet strategic nuclear forces. And when we go into the post-Cold War era, we find that Russians today are still very concerned about this program. They're still very much concerned about a reinvigoration of certain elements of SDI. Myth number 4 is that SDI was canceled at the end of the Cold War. SDI really led to a permanent infrastructure in the United States for missile defense. It's out of the Strategic Defense Initiative Organization that managed SDI R&D that we ultimately get the Missile Defense Agency. So what I like to tell any audiences that I speak with is that SDI did not disappear. It was just reoriented after the Cold War came to an end. So the key points in the book, that SDI was heavily shaped by changing views in the United States on the relationship between space and national power. SDI is oftentimes framed as this bolt out of the blue program that Reagan introduces. There was a lot of accusations at the time that SDI would lead to the militarization of space. In reality, space had been militarized since the beginning of the space age in 1957. But what we find in the 1970s is that US officials, particularly in the Department of Defense, but all the way up to the level of the White House, are starting to think differently about the role of space technologies in American national strategy. And it's in the 1970s that we find this much more competitive view of space, that the US needs to be pursuing offensive space capabilities as a means of securing qualitative advantages over the Soviet Union, and I will unpack that in greater detail. The second aspect of this is that SDI was an international project. By 1990, you have West Germany, France, Britain, Japan, and Israel all participating in SDI. And why this is important is that it really reframes the militarization of space in this period as an international phenomenon that transcends the bipolar superpower dynamic. Point number 3 is that space arms control failed in the 1980s, largely due to disagreements concerning space-based missile defense. So if we think about the arms control narrative of the 1980s, it's mostly positive. Out of these arms control negotiations, we get the INF Treaty and then we get START. But we need to remember that these arms control agreements grow out of this thing called the nuclear and space talks. While the nuclear component is indeed successful, the space component is largely a failure. And a lot of those issues left unresolved between Moscow and Washington continue to haunt the international dialogue on stability in space today. So even though SDI did not result in the deployment of space-based interceptors, what we find is that the program is still very much present in that international dialogue on space. So just briefly talking about the methodology behind the book, I reviewed something like 20,000 pages of archival documents from the United States, Western Europe, and the former Soviet Union. Because I cannot travel to Moscow for fairly obvious reasons, I had to rely on materials that the Soviets left behind in the republics. And so in particular, I was fortunate to find quite a lot of valuable material in Lithuania, KGB assessments on not only SDI, but American nuclear forces writ large. The Reagan Presidential Library has declassified a lot of relevant material, but really where I actually found a lot of valuable documents was in the British National Archives. There's a lot of material that was lost in the United States when a lot of these materials were transferred, but fortunately, because the British were heavily involved in SDI research and development, the US government shared quite a lot of technical information with the British Ministry of Defense, and I was able to use that in a way as a backdoor into the SDI program. So before proceeding, I think it's necessary to just talk about what was SDI and to really define what the program consisted of. And so, as I mentioned earlier, SDI is oftentimes talked about as this space laser initiative, when in reality, SDI was just an umbrella program for all kinds of research efforts into advanced technologies for land and space-based missile defense, but also space warfare. Certain kinds of technological demonstrators also had use for things like offensive space control. being able to destroy Soviet satellites in a wartime situation. So I'm going to talk more about the technological evolution of the program, but if you look on the left-hand side of the slide, you'll see the first phase of a strategic defense system. This was adopted around 1988. You won't see lasers anywhere in this particular concept. And so the system that was actually settled on consisted of land and space-based kinetic interceptors supported by satellites that could be used to track and target ballistic missiles in all phases of flight. And really the center of the concept was Brilliant Pebbles, which you can see on the right-hand side and also right behind me. And Brilliant Pebbles was supposed to be the main interceptor for going after Soviet ballistic missiles in their boost phase of flight. And Brilliant Pebbles is a product of Lawrence Livermore National Lab, as I will talk about in a few moments. So why the emphasis on boost phase defense? The emphasis on boost phase defense came from the fact that mid-course defense is really, really difficult, being able to discriminate between warheads and countermeasures. And so the idea was that if we really want to be able to defeat a significant percentage of Soviet strategic forces, Soviet ballistic missiles, we need to be able to target them in that critical boost phase of flight, but that would require putting interceptors into space. And that was a really politically contentious issue. And the reason why is the idea that the United States is going to deploy large numbers of weapons in space really seemed to contradict longstanding U.S. policy committed to the peaceful use of outer space. And so really the controversy over SDI wasn't just one of technological feasibility, but this international controversy over placing weapons in space. So I really want to unpack, where did SDI come from? There's a lot of near-term and long-term factors, but today I really want to focus on the space elements of the program and how SDI grows out of these transformations in the 1970s on changing views in the United States about the military use of space. So as I mentioned earlier, going back to the beginning of the space age, the United States is using space for national security purposes, intelligence gathering. In the early 1970s, the U.S. is deploying nuclear early warning satellites. Communication satellites are the foundation of American global projection, power projection capabilities, both for nuclear and conventional forces. So space militarization long predates the 1980s and the advent of SDI. But what's going on in the 1970s is both the United States and the Soviet Union start to use space in a different way. And in particular, the US and the Soviet Union are starting to deploy satellites to more directly support tactical military operations. The Soviets, by the middle of the 1970s, have deployed a constellation of radar satellites that can track naval vessels in near real time and provide targeting information to anti-ship ballistic missiles. The US is deploying its first set of near real-time imaging satellites that can provide data to the US military to more precisely target Soviet forces deep behind enemy lines. So fundamentally, what's going on in the 1970s is a tactical shift in the use of space systems. The other important detail is that by 1975, the Soviets are intensifying testing of a co-orbital anti-satellite weapons capability. So this is designed to be fired off into space, maneuver close to US satellite systems, and use a conventional munitions to destroy those satellites. So as a consequence of all these shifts going on in the 1970s, President Gerald Ford in 1976 puts together this panel under former presidential science advisor Solomon Buxbaum, a highly classified study that was only declassified in 2014. And the main conclusion of this study is that it's against the US national interest to treat space as a sanctuary, that conflict will extend into space if there's going to be a clash directly between the superpowers. So even though we think of space as a warfighting domain, as a novel concept or a post-Cold War construction, that's not really the case in reality. But none of this was really put into the public sphere. This was all going on within discussions in the US interagency. But as a consequence of this study, in 1977, specifically January of 77, in President Ford's last 48 hours in office, he initiates a new US anti-satellite weapons program, ultimately becoming the Miniature Homing Vehicle Anti-Satellite Weapons Project, which you can see in the right-hand side there. It was a concept for an air-launched anti-satellite weapon. it would only be tested once against an object in space in 1985. Technologically, this new anti-satellite weapons program was going to rely on kinetic kill vehicles, the idea being that you use kinetic force to destroy an object in space. And a lot of the key technologies that SDI would rely on were synonymous with these technologies being used for counter space purposes. So there's an intimate linkage between missile defense technologies and counter space capabilities. But the thing that I really want to emphasize here is that it's in this period before Reagan comes into office that we see this much more militarily competitive approach to space emerging. Didn't make SDI inevitable. Under the Carter administration, the US would pursue anti-satellite weapons arms control with the Soviets, but those negotiations would ultimately fail. And once the Soviets invaded Afghanistan in 1975, the arms control dialogue was totally derailed. So how do we actually get to Reagan's speech in March 1983 that leads to the Strategic Defense Initiative? I think it's really necessary to stress that more so than any other president during the Cold War, Reagan was a space enthusiast. The New York Times described him as the biggest space enthusiast to have occupied the Oval Office. And what's important to understand about Reagan is he believed that space was really important to demonstrate American leadership on the international stage. He used to talk about American space leadership and reinvigorating it. But he had this very Mahanian view of space, the idea being that space had great commercial potential for exploiting commercial opportunities in space, but that had to be buttressed by military power. And so in July 1982, Reagan makes a speech after the space shuttle lands, really talking about how space is going to play a key role in American national security strategy. But the other thing that's important to understand about Reagan is that he sees space as a domain of direct superpower competition. So in 1982, he initiates a national space strategy study, which you can see an excerpt from here on the left-hand side of the screen. And it's based on the premise that the Soviet Union has initiated a major campaign to capture the high ground of space. When Reagan comes into office, the US intelligence community is reporting to him that the Soviets are spending the equivalent of billions of dollars on both counter space capabilities and also strategic defense. And so Reagan sees a gap in US and Soviet research and development in these key areas, and it's a gap that he wants to fill. And he's very concerned that if the United States does not meet this Soviet threat head on, that there's going to be a shortfall in US capability. So that's kind of the broader context for the decision. The immediate cause was the MX basing debacle. So how is the US going to deploy a survivable ICBM, known as MX, or rather, how can the US find a survivable basing mode for MX? And the Joint Chiefs of Staff were really split over what would this basing mode look like. So there were multiple contentious meetings on this subject in the fall of 1982. And at one of those meetings, Ronald Reagan said to the chairman of the Joint Chiefs, well, what if the US pursued a strategic defense capability? Is that indeed something that we should consider doing? By this point, Reagan was already convinced that this was technologically possible, that the time was right. And what's important to realize is that Reagan did this totally outside of the US interagency process. He did not inform the Secretary of Defense. He did not inform the Secretary of State. And he believed that if this was put through the formal interagency channels, it would be killed because there was such overt hostility to initiate any kind of large-scale missile defense effort. So in early March of 1983, the president decides to insert these lines about rendering nuclear weapons impotent and obsolete through a large-scale technology research and development effort. And that was done totally without any kind of warning to most of his senior advisors. So there's a competitive aspect to the initiation of SDI that Reagan is sincerely concerned about the Soviets, but the president was also a nuclear abolitionist. One of the great ironies about Reagan is that he's leading the US in this nuclear forces modernization, but at the same time, Reagan believes that strategic defense can provide a pathway out from under the threat of nuclear annihilation and a deterrent strategy based on nuclear weapons. So in March 1983, Reagan inserts these lines into this televised address in which he calls upon American scientists to develop the capability to render nuclear weapons impotent and obsolete. And it's important to realize that Reagan said absolutely nothing about space-based weapons. He didn't say anything about lasers. But very quickly after the speech, Senator Ted Kennedy describes this as more or less a Star Wars fantasy, and that's where the Star Wars moniker for SDI comes from, and Reagan always viewed that as a pejorative. But what's also important to recognize is that Reagan had no idea at this point for what kind of technologies might indeed be used for strategic defense. It was just a broad concept with no actual program in place. It's not until January of 1984 that the Department of Defense establishes the Strategic Defense Initiative Organization to manage all U.S. Research and development into technologies that can be used for missile defense. And so it would really be more accurate to call the Strategic Defense Initiative the Strategic Defense Initiatives, plural, because it really wasn't just one program. It was a massive number of research efforts into missile defense technologies, but also space systems to be used for tracking missiles in all phases of flight. The other key thing to realize is that the vast majority of the funds being expended under SDIO were for the command and control software and sensors for linking all of these capabilities together to do missile defense in all phases of flight. So the Soviet response to SDI is overwhelmingly negative. Yuri Andropov, the General Secretary of the Communist Party of the Soviet Union, the leader of the Soviet Union, denounces SDI. He says that in effect, it's a program that the US is going to use to initiate a first strike against the Soviet Union. The Soviets put together this very large anti-SDI propaganda machine and really try to undermine any support for the program, both domestically in the US, but also among US allies. But also immediately after Reagan makes his March '83 speech, Andropov proposes to a visiting group of US senators that the US and the Soviet Union enter into negotiations to limit anti-satellite weapons. So why the sudden interest in anti-satellite weapons? Well, Andropov realizes that if the United States will agree to constraints on anti-satellite weapons, that's going to constrain the US ability to develop technologies that can be used for missile defense. And here we find this missile defense ASAT entanglement becoming a key problem in the arms control negotiations. And Andropov makes it absolutely clear to Reagan that if he wants to see progress in the nuclear arms reduction arena and to advance the nuclear arms dialogue, then there's going to have to be constraints placed on SDI and what the Soviets referred to as space strike weapons, which would include both space-based missile defense and anti-satellite weapons capability. So the strategy here being pursued is get the US to agree to anti-satellite weapons arms control in the near term, and that's going to make it more difficult for the US to pursue strategic defense capabilities in the long term. And the Reagan administration is vehemently opposed to any kind of constraints on US military space capabilities. But SDI also quickly becomes a source of contention among the transatlantic allies. We have to remember that 1983 is a really contentious time period in transatlantic relations. The US is preparing to deploy intermediate range nuclear forces, Pershing IIs, and ground launched cruise missiles. The Soviets have walked out of the arms control negotiations as a consequence of the deployment of intermediate range nuclear forces, or rather because the US and the Soviet Union couldn't agree to limits on these weapons. The US is pushing forward with deployment. So there's rising anti-nuclear sentiment in Europe at this time. The other thing that's important to remember is that the British are modernizing their nuclear forces with the assistance of the United States. And then Reagan comes along in March of 1983 and totally surprises the transatlantic allies when he talks about developing a deterrent strategy based on strategic defense and not nuclear deterrence. And so this really becomes a source of tension in US relations with allies in Europe as they're grappling to understand what does this mean? And we also have to remember that because SDI wasn't really well defined, the allies didn't have a clear idea of even what was being pursued. The US hadn't consulted any allies ahead of the speech. So most of the US allies in Europe adopt a wait and see attitude and are more or less very quiet, just trying to figure out more about what Reagan has in mind. The French are vocally opposed to what they call the weaponization of space, and the French are pushing for space arms control very much along the same lines as the Soviet Union. And this all becomes a real problem for Reagan. Reagan wants to have progress in arms control negotiations, and he needs Allied solidarity behind him. But most importantly, to advance SDI, Reagan needs Congress. And if the Allies aren't on board with SDI, that's going to be really difficult to advance the effort. So Reagan sees Allied solidarity as really, really key. So ultimately, what the United States does is develops a strategy that if we can get the Allies involved in the program, then that's perhaps going to build more consensus in favor of SDI, especially among members of NATO. So ultimately, what the U.S. tries to do is to use the prospect of technology transfer through SDI research and development to get the Allies into the program. And we have to remember that SDI technologies have a wide variety of applications. So if you look at the long list of technologies, everything from advanced optics, more advanced software for command and control, a lot of technologies that are dual use. So the Allies are interested in SDI, not just because of the missile defense applications or the defense applications outside of missile defense, but also because of the potential civil applications of the program as well. So in early 1985, U.S. Secretary of Defense Caspar Weinberger invites a number of U.S. allies to become involved, mostly NATO countries, but also Japan and Israel. And the response among U.S. allies to that invitation is fairly tepid. And there's a lot of concern that the U.S. isn't actually going to be willing to share sensitive technologies under the SDI heading with them, because there had been really significant complications concerning technology transfer with U.S. allies in the past. The other issue is key allies in West Germany and Britain don't want to be seen as endorsing a program that is overtly connected with Reagan's nuclear abolitionist rhetoric. So Margaret Thatcher, for example, Prime Minister of the United Kingdom, she believes that SDI research and development is necessary as a hedge against a Soviet breakout in these technologies, but she's a hardcore believer in the importance of nuclear deterrence, and she doesn't want to be seen as signing on to an initiative that's going to undermine nuclear deterrence, or rather a strategy based on nuclear weapons. And so this creates a real complication. So ultimately, in December of 1984, Thatcher convinces Reagan at Camp David to issue a statement in which he says the U.S. is not pivoting away from a deterrence strategy based on nuclear weapons. SDI is only a long-term R&D effort, and that the U.S. isn't going to move forward with deployment of strategic defenses without negotiations with the Soviet Union. And there's, of course, significant concern about how SDI might impact the 1972 Anti-Ballistic Missile Treaty, which limits both U.S. and Soviet missile defense capabilities. And Reagan, of course, sees the 1972 ABM Treaty as one of the most significant impediments to moving forward with SDI in the long term. So this statement from Reagan at Camp David is really seen as a way to make the path a little bit clear to getting allies involved in the program. And ultimately, the British would be the first key ally to negotiate a memorandum of understanding to become involved in SDI research and development, followed by multiple other countries in Europe, and then ultimately Japan and Israel. And a lot of Israel's modern missile defense efforts grow out of joint research with the United States under the SDI umbrella. But the other point that I want to make is that even though the French were vocally opposed to what they called the weaponization of space, the French actually proposed a French SDI equivalent, that there could be a European-wide space-based missile defense effort. And what this really underscores is that the French were not opposed to placing weapons in space. The French were not opposed to strategic defense. The French were really opposed to a program that was American-led and getting the European allies even further dependent on American advanced technological programs. And so a lot of this kind of lofty language about limiting weapons in space really obfuscated these larger issues within the transatlantic alliance, and concerns about a growing technology gap between the United States and Europe. But even though you have all of these allies becoming involved in SDI research and development, that in no way, shape, or form really solves this problem of Allied support, and key allies would remain opposed to the deployment of any kind of strategic defense capabilities, as we'll see in a few moments. The other issue that Reagan has to face is that he wants to actually build momentum for strategic defense. He wants to get this off the drawing board, and he wants to actually have a timeline for moving forward with deployment of strategic defense sometime in the near term. So as a consequence of this, the Strategic Defense Initiative organization realizes that these longer term concepts to use directed energy weapons, for example, to be able to shoot down ballistic missiles in all phases of flight, those technologies aren't going to mature until the end of the century or perhaps the 21st century at the earliest. So as a consequence of that, SDIO begins focusing on what are known as near-term solutions, and in particular relying on land-based and space-based kinetic kill vehicles to go after ballistic missiles in their boost phase of flight. The key problem is that the initial concept for the space-based interceptors would involve putting a bunch of, in effect, missiles into a garage in orbit, in low Earth orbit, that's going to house the missiles and fire them off at Soviet ballistic missiles in their boost phase of flight. The key issue is that those garages in space would be vulnerable to Soviet anti-satellite weapons. And so the head of SDIO, Lieutenant General Jim Abramson, says, look, these garages in space are going to be sitting ducks. And so the space-based component of SDI needs to be survivable. It needs to be distributed. We can't have them housed together in clumps. So as a consequence of that, Lowell Wood here at Lawrence Livermore comes up with the concept of brilliant pebbles. The idea being that we're going to have one space-based interceptor housed in what's known as a life jacket. And there's going to be a suite of sensors on board that are going to allow it to more effectively target ballistic missiles in their boost phase of flight, and that these are going to be supported by satellites known as brilliant eyes that are going to actually be doing the more exquisite tracking of ballistic missiles in all phases of flight. And so between 1986 and 1989, all of these different concepts are examined, and ultimately SDIO settles on brilliant pebbles as really the optimal technology for a first phase strategic defense system. And Lieutenant General Jim Abramson tells the president that it would indeed be possible to deploy brilliant pebbles, at least an initial phase of brilliant pebbles, by the mid-1990s, that these would be complemented by land-based missile defense interceptors to go after ballistic missiles in their mid-course and terminal phases of flight. But brilliant pebbles is really seen as the most important element of a first phase strategic defense system. The other problem this creates is that brilliant pebbles is going to require testing components in space that are going to potentially violate the 1972 Anti-Ballistic Missile Treaty. And so what Reagan needs to do is either renegotiate the treaty or abrogate the treaty. But the Soviets have made it explicitly clear that any change to the ABM treaty is going to result in significant obstacles to moving forward with advancing the nuclear arms dialogue. So there's this linkage issue that Reagan is going to have to negotiate. So in 1985, the nuclear and space talks are getting underway. And as I alluded to earlier, this is looking at potentially limiting or reducing intermediate range nuclear forces, strategic nuclear weapons, and then the space component involves anti-satellite weapons and missile defense. And so this missile defense linkage with nuclear forces is really the main problem as Reagan is trying to advance the Strategic Defense Initiative. And so Mikhail Gorbachev is now the General Secretary of the Soviet Union, and he is really eager to make progress on this nuclear arms issue. And so there's multiple back and forth at the Geneva Superpower Summit in '85, at the Reykjavik Summit in '86. Somewhat famously, Gorbachev proposes to eliminate all US and Soviet nuclear forces if Reagan will just agree to limits on SDI. Reagan refuses. They walk away from the Arms Control Summit without any progress. So ultimately, what Gorbachev decides to do in 1987 is to de-link SDI from negotiations on intermediate range nuclear forces. And why does Gorbachev make this decision? So for a long time, the narrative was, well, SDI bullied Gorbachev into making these concessions, and that's not really the case in reality. What happened was Gorbachev was convinced that if the US moved ahead with deployment of space-based interceptors, The Soviets could deploy faster burn ICBMs. The Soviets could deploy more anti-satellite weapons to destroy the space-based components of a strategic defense system. And so the Soviets were convinced that they could deploy countermeasures that would render a strategic defense system less effective. And so that gave Gorbachev greater confidence that this delinkage was prudent. But even more importantly than that, the Soviet economy had placed Gorbachev in a situation where he really needed an arms control agreement to rein in Soviet defense spending. And so he needed this delinkage to move forward with intermediate range nuclear forces negotiations, which resulted in the 1987 INF Treaty. So moving into the late Cold War, the late 1980s, US-Soviet relations are improving, and this actually creates a significant problem for Reagan. And this creates a significant problem for his successor, George H.W. Bush, in moving this program forward. A lot of folks in Congress are saying, well, if the Soviets are no longer the key adversary, as the Cold War is coming to an end, why are we going to spend billions of dollars to deploy a strategic defense system of land and space-based interceptors? The space component is still really controversial because the Soviets are warning the United States that any back out from the 1972 ABM Treaty could really become a problem in the broader arms control negotiations going on. So ultimately what happens moving into the early 1990s is the Soviets also delink SDI from negotiations on strategic nuclear forces, which results in START. And as this is taking place, funding for the space-based component of SDI is being cut. In moving into the Clinton administration, Bill Clinton would ultimately cut all funding for the space-based component of SDI. The other problem is that Brilliant Pebbles would be flight tested 3 times, and those 3 flight tests were indeed failures. But in one important case, none of the flight data was actually returned, so it's difficult to know what indeed occurred. But the key thing I want to emphasize here is that oftentimes SDI is framed as a technologically infeasible effort. And really, we have to unpack what technologies we're talking about. If the US had wanted to move ahead with deployment of Brilliant Pebbles, it certainly could have. How effective Brilliant Pebbles would have been is another issue. But it wasn't really a problem of technological infeasibility. It was the changing international political conditions that just made it increasingly difficult to justify strategic defense research on this scale. So ultimately what happens in the Clinton administration is Star Wars, so to speak, is brought down to earth, and the US is now just focusing on land-based interceptors for mid-course and terminal phases of flight and using satellites for tracking missiles in all phases of flight. And this is really the architecture model that persists up through the present time. If we look at the ground-based interceptors that the US has deployed for mid-course defense, and then a wide range of systems for theater and terminal defense. So if we think about what actually happened in this strategic defense system phase 1, the key portions that are cut are Brilliant Pebbles, with other elements remaining in place. Brilliant Eyes, or at least some of the technologies going into Brilliant Eyes, would be used for follow-on nuclear early warning satellites in the form of SIBRs. So if we think about the legacy of SDI, there's a couple of things that I want to emphasize. There's the political aspect of it, that if we think about the arms control negotiations in the space segment fail largely due to SDI. So even though the US and the Soviets and the US and the Russians in the post-Cold War environment have INF and START, no new agreements would be reached on limiting military activities in space, largely due to disagreements over SDI. And so if we think about these issues left unresolved about what should the boundaries of military activities in space be, that debate is still ongoing today. And as I mentioned earlier, there's still intense concern in Beijing and Moscow that the US could indeed reinvigorate aspects of SDI and deploy proliferated space-based interceptors that could pose significant challenges for Moscow and Beijing's nuclear forces. Another technological legacy of SDI is a focus on proliferated space assets. So if we look at the architecture being pushed by Space Development Agency today, A lot of those ideas are really going back to ideas and concepts promoted by the Strategic Defense Initiative Organization, having proliferated satellites in low Earth orbit to track missile threats in all phases of flight. I should also state that the Space Development Agency was modeled on the Strategic Defense Initiative Organization. Mike Griffin, the Undersecretary of Defense for R&E in the Trump administration, was heavily involved in SDIO and specifically modeled SDA on that organization. And so from a technological standpoint, when we hear about proliferated constellations, we need to understand that SDIO is a key part of the genealogy of that architecture that's being pursued at the present time. So just a couple of concluding ideas. I think it's really important to stress that even though there's this narrative that the 1980s is a real turning point in the way that the US is approaching space, that SDI is going to lead to the weaponization of space, at the very least, a more militarily competitive approach to space emerges in the 1970s when the US begins to pursue these counter space programs, such as the Miniature Homing Vehicle Anti-Satellite Weapons Project. Other point that I want to emphasize is that SDI was not one thing. So when people talk about the infeasibility of SDI, I need to always ask, well, what specific technologies are you talking about? Are you talking about the sensors that could be used for tracking missiles in all phases of flight? Are you talking about kinetic kill interceptors for mid-course and boost phase defense? Fundamentally, it was a family group of research efforts into a lot of different technologies with missile defense, space warfare, and other military applications. Third point is that space arms control failed in the 1980s, largely due to disagreements concerning space-based missile defense. So from an international political standpoint, the program certainly left an indelible imprint on the final years of the Cold War, specifically concerning the arms control negotiations. And these space security issues left unresolved in the 1980s continue to have a significant impact on international discussions concerning stability in space today. And so with that, I look forward to your questions and comments.